Number 6, find the critical points of this function. Determine whether each point, this time we got to determine, is it a maximum, is it a minimum, or a point of inflection? Well, I know x cubed minus 3x squared plus 4. I know that's a graph that's swinging down, swinging up, swinging back. So right here will be our minimum. Right here is going to be our maximum point of inflection right there. So let's see what happens. Well, what do I know? I know that right here at this minimum, what's the slope right there of the tangent line? It's going to be 0. And the slope of that tangent line, 0. So what we're going to do is we're going to take the derivative, which tells us the slope at any point, and then set that derivative equal to 0. That'll help us find this point and that point. So I need to take the derivative. F, derivative of x, is 3 comes down in front, 3x squared. The 2 comes down there, gets multiplied by the 3, so 6x, power drops by 1, and then the 4 disappears. So it's just 3x squared minus 6x. I now need to set that equal to 0 because I'm saying, hey, this tells me, 3x squared minus 6x tells you the slope anywhere on that blue line. I want to know, when is that guy equal to 0? When is its slope 0? Now, I'm going to factor this. I'm going to factor out a 3x, leaves me behind an x minus 2. So I'm going to set this piece to 0 and that piece to 0. 3x is 0, x minus 2 is 0. I can see here, oh, it happens when x is 0 and when x is 2. Knowing the graph looks like this, that means that's at 2, and then I don't know its height, somewhere low. This is at a height at an x of 0, but I don't know what the height is there. So we're going to figure it out by plugging it into the original equation, this guy, because the blue line is the x to the third minus 3x squared plus 4. And we're trying to say, hey, where's that? I know it's what happens when x is 2, so just plug 2 into the x there. So that's what we're going to do. Okay? We're going to plug 2 into the x. So I want to plug 2 into the original equation. So it's going to be 2 to the third minus 3 times 2 squared plus 4. That'll tell us the height. So that's 8 minus, this is 4. 4 times 3 is 12 plus 4 gives us 0. Happens at 2, 0. Let's try that again. 2, 0. And that's going to be a minimum. Our maximum is going to be when x is 0. So let's plug 0 into this original equation. 0 cubed minus 3 times 0 squared plus 4. That's 0 minus 0 because 0 squared times 3, 0 times 3 is 0. That goes away. I'm left with 4. So it happens at 0, 4. The point of inflection is right here. How do I get that? Well, we take the second derivative and set it equal to 0. So here's our first derivative right here. So our second derivative, the derivative of the derivative, 2 comes down, it makes it 6x minus 6. And I now just set that equal to 0. Move your 6 over. 6x is 6. Happens when x is 1. This is occurring right at 1. Now, all I got to do is plug 1 back into the original equation to find the height where that 1's associated with, to find this height right here. So 1 cubed minus 3 times 1 squared plus 4. So that's 1 minus 3. 1 squared is 1 times 3 is 3 plus 4. So you get negative 2 plus 4, 2. So this occurs at 1, 2 is your point of inflection.